Hi, good morning, everyone. So, welcome to Big Data Analysis. Okay. Uh, Today, we will learn about more detail on Big Data Analysis, which is about statistics. Okay. So, I will start with the project that I have done, so that you can see what we are doing. Okay. So, this project has been done with support from Toyota, Japan. Okay. I think the report is already in Lentera, isn't it? No? Can you see the report in Lentera? Okay, so the report is something like this. I will share this. Okay, this is my, yeah. This is about almost 1 million data of traffic accidents, I think 12 years in Metro Manila. Okay. So, as usually, okay, what happened is this. In the traffic report, okay, if there is an accident, for example, the police will report where the location, right, of the accidents. So this is based on the police record. Okay. So Metro Manila is like it's a province, yeah. It's one big province like Jakarta Raya, like that. Okay. So it consists of 17 cities. So Manila is one of them, right? So, and the government is called Metro Manila Development Authority, or MMDA. So this report is based on MMDA report. Okay. And what happened is they identify the name of major highway, okay, without specific intersection where the accident happened. For example, okay, the name is Commonwealth Avenue, Epifanio de los Santos, ETSA, Quirino Highway. These are the example of data that they reported. And this is also what the news always saying, right? So, but the name of Epifanio de los Santos Avenue, ETSA, is actually 23.8 kilometers. Okay, what they report as Commonwealth Avenue is actually 12.4 kilometers. So it's like entire ring road of Metro Manila. So this kind of reporting is actually not so useful because we don't know where the actual accident happened, right? And so this is example the report that we put. They also have the way of reporting is not standardized. Okay? Sometimes they report ETSA, sometimes they report Epifanio, and so on. So this is example of the report that they put. Okay, so because of this, there are so many, almost about 1 million record of dirty data. They are all in text string, right? So if you do manual cleaning one by one, this is like a nightmare, right? 1 million data, you need to check one by one manually. So, and many of the name variation is also actually the same location. These are the examples, right? So what we are doing, so I have 3 staff for a month, for example. They do manual work and they can produce only 20,000 rows. Okay? So for 1 million rows is like a nightmare for them. They have very high level, high stress level, and then finally after a few hours, their work is actually producing inconsistent result. Okay? So this is what they are doing is not repeatable. So then I said, okay, let the computer do this. Okay, so this is what I'm doing. So I created what is called finite state machine. So very simple. Left-hand side will go to the right-hand side. We call this a string rewriting system. The nice thing about it is it's consistent, the result is programmable and also repeatable for the future data, and also improvable if we think this is wrong, so we can run again. Okay. So now the data you can the result of the data, I put it in GitHub already, so you can also download if you want to see. Yeah. This is the consists of almost 1 million, right? 500 plus 400 something. Yeah? Because GitHub does not allow me to upload that big data, so I need to separate into two parts. Yeah? And this is only geocoding data. That means only time, and then classification, and then the location. Yeah? The actual data is more than 100 variables. Okay, and the result after I get the geocode, this one, because I know the location already. Okay? I can now plot it in the map. Okay? I can see where the actual problems of all the accidents, for example, or accident with injury only, okay? Or number of fatality. You can see here where is the actual number of death happen, yeah, in the entire city. The red part here is the actual problem. Okay, and then number of accidents by the victim role, whether this is driver or passenger or pedestrian and so on. So we can actually start to create a crosstab table. Okay, and then I can start to count where the actual top accident happened and the intersection, right, including fatality and injury and pedestrian killed. And I started to rank the most dangerous intersection. Okay. And what happened? This is the black spot, meaning the total number of deaths that happened in this place, okay, the intersection. And I know already, because of my analysis, I can recover, okay, where is the actual coordinate, okay, where in the actual map. Okay. And as I analyze this, okay, it happened that there is exactly the same spot that I show during the conference. There was accidents. Okay? So in the news again. So this is the actual spot we put in the Google map. Yeah? Okay, and this is the actual location, is something like this. So it is a major highway with 12 lanes. Yeah? That's why it's a big accident. Something like that. You see, the pedestrian is crossing in this major highway, even though there is a pedestrian crossing there. Okay, with all the bus and jeepney. So we are able to systematically identify the top accident location from the traffic accident based on very dirty data using a semi-automatic system. Yeah? So this is an example of a project that I hope you can create in your group project. Okay. So, and I want to show you a little bit more detail, which is not in the Lentera. Okay. So I will close this one. This is the Lentera. The big data. Okay. Where is? Oh, here. Okay, so this is the data we analyze. I analyze using Python. Okay, so this is using Jupyter. If you want to use this, you can also use using Google Colab. Okay, so Google Colab. Okay, let This is the data that you can download in GitHub. Metro Manila traffic accident data. I will share it with you in the Zoom. Right? Where is this one? Chat. Okay. So you can visit this if you want. And then here it is. This is the pattern analysis. Okay, so we start with creating a univariate distribution, and then we calculate the summary statistics, and right, to make the summary table of statistics, right, and then the description, frequency distribution. This is the usual technique in data analysis. Okay, and this is what we are doing today for the lecture. Okay, say the data file is named derived data CSV. Yeah, this consists of a million of data. So you can see here I use Panda to read the CSV. Okay, because your data is very big, so you need to write down memory faults, other low memory faults, so that it can use to open big data. Otherwise, your data cannot be big data cannot be opened. Okay, and these are the actual variables inside the data. Yeah, if you open this data because it's very big in Excel, it takes sometimes. So this is the number of data, 900. What is this? 957 rows. Yeah, with 116 columns. Right. After that, we can start to analyze one by one. So you can calculate the frequency distribution, right? And then after you analyze, you interpret. And then say, for example, this is the city. When you start to see the distribution, okay, and then you can start to see the actual plot. Then you start to interpret one by one. Okay. This is how you will do a one way, yeah? One univariate distribution analysis, meaning that you only do for one per variable. Okay. Next is to do what is called bivariate analysis. Again, we can use Panda. Okay. So the same data, right? And now you are doing every two variables, you put it one by one. Okay. This is an example. So, and then you can calculate what is called chi-square. Okay. I hope we can discuss about it today. Okay. So these are the example of result. Okay. See, two variables. Okay. One variable on the column and one variable in the row. Okay. And then you calculate the probability of row, columns, and total probability. From here, you can calculate many things. Okay. Okay, I will stop sharing. Okay, tell me what did you get from this experience of demonstration of the project? Is there any feedback?
Sir, so just now you said that for the group project, we need to do coding, yeah, sir, just like what you did, what you showed us.
Copy and paste.
Oh, just copy and paste the coding or?
To copy and paste into coding.
Oh, so you will teach us today how to do
Not
it, sir?
today, but today I will discuss about the concept of statistic and what analysis you want to do, and you try first, okay? And if you cannot, then we can I can have a special session for you on the coding itself. Because actually all of these are in the internet already. This is nothing new, right? So, but if you have difficulty, you tell me, then I can change some of the curriculum and then to accommodate what you need.
Okay, sir. Thank
Okay.
you.
Okay. So, uh, why did you ask that?
Because honestly, my group and I, we are confused about the group projects or like how to do it, about the coding one.
You are afraid about the coding or you are afraid about the data?
We haven't decided what data we want to take and discuss for the group project, but yeah, we are also afraid that we cannot use the coding, sir.
Coding is easy, you just copy and paste only and then run. There is nothing there, right?
So we will use the website that before you use, yeah, or
Or you can, I have a website that you can use for the coding, right? Wait, I will tell you. Where is my website? Oh, here, this is my website. I will put in the chat, right? For the coding of the Python, you can, this is the Python things that you want to do. And then for data analysis itself, I think I already put it here. This is, so all you need to do is just copy and paste. There is nothing new here. So here is example, right? So you just copy and paste this one, for example, right? And then this is the data, so you have the sample data here, and then you read, right? See exactly here. Copy and paste this. Or you want to practice this? Later, after you know the concept first, and then we can practice this, okay, if you want. But you try on your own first, okay? Then you can start to see your problem. Because if you did not face any problem and then we start to practice, you will not have any question, just copy and paste without thinking, isn't it? So I want you to do it the other way around. So I want you to struggle first so that you can think, okay? And then I can help you. That's the way to learn, okay? Just spoon feed on you on how to do and copy and paste will not make you learn anything. That's not the way to educate people. Okay, make you struggle a little bit, and then you start to see, oh, this is my problem. Then we can discuss how to solve it. Is that okay?
yes, sir. So the website you have shared it on Lantera or
This one
before?
in the chat, I just give you
Oh, oh, I haven't received it yet, sir. I'm
in the
sorry.
chat in the chat today.
In the chat in Zoom, the
Zoom.
Zoom.
Yes,
Oh, I cannot find it, sir.
you cannot.
So it's actually the direct message to me, but I
Oh my
already sent it
goodness.
to my line group.
Okay.
Oh,
Sorry,
okay.
sorry, because
Yes, sir.
apparently
Thank you.
it go to Axel only. Okay, sorry. Okay, I will share it again. Hmm. Can you see it?
Oh, yes, sir. Thank you very much, sir.
Okay. Sorry. I did not notice it will go to Axel only. Okay, go. What else? One more things about the coding. When I said coding is actually this way. Yeah. This is what I call by coding. This is, you need to do it manually. Okay. For every data, okay, for every data, you need to, or every derived data, okay, you need to decide the data type, whether it is numerical, categorical, or binary. Okay, so this is the example. Okay, the row, for example, numerical, right? N is numerical, C is categorical, B is binary. So district, okay, for example, the name of the variable is district, right? C mean categorical, and then what is the coding? Okay, coding mean the actual values in the Excel. Okay, it's supposed to be central, eastern, northern, southern, western. So then you code. Okay, central mean 1, eastern mean 2, northern mean 3. Okay, and then for example, this is the name of the city there. Huh? So city is categorical, right? So then the meaning is where it happened, right? Where it come from. So it's come from the MMDA, and then you need to code. Okay, coding mean for each name of the city. Now you put number 1, 2, 3, 4, so that you can bind the name of the text into numbers. Can you get this? For example, junction type. Okay, this is example here. So then you can start to recode what is the meaning of junction type here. So 1 is 2 junction, K is 3, K junction is 2, U-turn is 3, and so on. Do you get it? Okay, if you don't get it, let's go to the okay. Let's enter the actual lesson then. So this is the slide on questionnaire data analysis. You can follow this in Lentera. Can you see it in Lentera? No, there. Data analysis from questionnaire. Can you?
Yes, sir.
Good.
Yes.
And now I will show you where it is in my website. Data analysis. Oh, there. Okay, I will share you the actual chart. Everyone. There. So the text of this data analysis is in my website. Okay. Here. Can you see that?
Yes, sir.
So the spreadsheet example, very short, you can download here. I hope you can download. Oops, you cannot. Anyway, my PSP is not working yet. Okay, I will show you the example. The data is something like this. Okay, let me show you in the slide so that you can see. Can you see my slide? Oh, okay. Anyway, so this website, okay, and the lecture that I gave you is also used in other places, right? Because this is long time ago, say 2008 already. Okay, this is actually based on my work in Japan, yeah, in Saga. university before. So they has been used by many people in different places. So the data actually, the actual data consists of more than hundreds, okay, 70 variables actually. So in this example, what I give you is only 6 variables. And then the actual respondent is also 100 of maybe 300 respondents. But in this example, I give you only 12 respondents, okay, and 3 public. Okay. So in Japan, we have public park, something like this. This is in Lincoln. Okay. Very big public park, right? So we have 6 variables. Okay. Here is one of them called family. Okay, so meaning per questionnaire. Okay, so my student distribute the questionnaire in the public park. Okay, and then one questionnaire is per family. Okay, so one person is including, if they are alone, they are included as one family. Okay, so family is the observation number of questionnaire. So one questionnaire was filled by one family, okay, not individual. So and then the time. Time here is quantitative data type measured in minutes. What is this? The meaning is the activity time of the family in the park. Okay. And then the mode. Mode here is nominal data type, categorical. Nominal means categorical. Yeah, consists of 4 choice of mode. So this is 1 is walking, 2 is car, 3 is cycling, 4 is bus. That means how do you go to the park? Okay. And look at this. The choice is mutually exclusive. That is only one mode for one family. Right? So if they cycle, so everyone will cycle. Not part of the family will go by bus. And then what is the activity they are doing in the park? So again, this is nominal data type. Yeah, categorical, and it has 6 choices: sport, picnic, reading, walking, meditating, and jogging. So what's the difference? Okay. The difference is this is multiple choice. Okay, they are not one. They don't choose one. They choose many. Okay, they can choose more than one activities in the park. So this is important. And then satisfaction, okay, is an ordinal scale. So it's called Likert scale. It's between -2 until +2. -2 is very dissatisfied. 2 is very satisfied. So this is measure the family satisfaction toward the park services. And the last one, whether they have children playground or not. This is binary, yes or no. Right? So, and this is the actual data after we code. No, this is the actual data that we gather from the questionnaire, and then after that we put into the, say, Excel. Okay. Do you still remember what is the meaning of mode 1 in here? Anyone?
Walking, sir.
Walking, is it? Oh, correct. Okay. So how about this? What is the meaning of activity 1, 2, 3 in here? Okay. So if you see activity 1, 2, 3, you need to check the coding. Yeah? The coding is 1 is sport, 2 is picnic, 3 is reading, right? Did you get it? So you need to code your data with this text into numbers. That is the first step in data analysis. You need to code. Why? Because computer only understand numbers. They don't understand text. Right? So the first step is to code, okay, to translate or to code the text into numbers. That is the first step in any data analysis. Yeah. So something like this. Okay, satisfaction is clear. How about this playground? Oh, still text. Yeah, yes and no. Right? And there's a problem here. What is the problem? One column can only accept one number. Right? For example, time is already one number, mode is already one number, but activities here is not one number. It consists of many numbers. So this cannot be analyzed. Right? Then you need to derive, okay? You need to create a dummy data, okay? Dummy variables. Okay? You need to create activities for each value. Then how to do that? To that, you create a binary. Okay, so something like this. You see? So for each activity, now you need to create the first family is 1, 2, 3, right? So 1, 1, 1 here. This is the coded data that you need to create first, okay, manually or automatically, it's up to you, but you need to create this coding. Okay? When I say coding, it's not computer coding, okay, but translating the actual data into code. Code means numbers. Okay, until here first. Is there any question? This is the first step in any data analysis. Is this clear or not? Hmm?
Sir,
Hmm.
so the first step is to determine what's the variable we use.
Of course, the variable you need to use is already included in the project, right? So, for example, maybe if you want to go earlier than that, the first step is actually to decide what project are you going to do.
Oh yes, of
Right,
course.
yeah, correct. After
Right.
that, you tell to yourself, okay, in that case, what variable I need to gather,
Yes.
right? So, and how do you gather that data, right? Okay, I think that is the first step if you want to do the project, right? But usually, these are like given. You already got that data, right? Supposed to be. If you want to do data analysis, meaning you already have the data, then you do analysis, right? But in the project, yes, you need to decide what project and then what variable you need to put. Right. So any business data, any even non-business is fine, right? Any data. I just show you a while ago about accidents. See? This is non-business data, right? So, but basically all data analysis are the same. Okay. Once you created the data, okay, or you gather the data, what happened is now you need to analyze. So what we discuss in this class is how to analyze the data, not to gather the data. Right? Gathering data is rather easy. You're supposed to get just copy and paste, all right? Okay. So and there are many ways to gather data. For example, using questionnaire is one way, right? Another is using experiments, okay, or using simulation. So, so these are the way to 3 ways to gather data, right? Using questionnaire, using experiments, or using simulation, right? Or using sensor, the other way. So if you use a sensing device or using, say for example, the transaction data, these are based on the scanner, right? So you can also gather that. Okay, so by this point, I hope you have already decided what is the project that you want to do, and then you're supposed to get the data already by this point. Okay. Otherwise, when we discuss about how you analyze the data, that's all meaningless without you have the data, isn't it? So, but anyway, imagine that now you have the data, what you need to do. This is what I'm discussing about, okay? So first thing is you need to code your data, right? So what do you mean by coding the data? Meaning that you will put that data that you have into numbers. How do you put that into numbers? You decide, okay, on your own. So walking is number one, jogging is number two, right? Or for example, the data is about male and female gender, right? The variable name is gender. Male is one, or male is two, okay? Or maybe female is zero, or female is one. It's up to you to decide the numbers. Okay? But this number represents the assignment between the value of the variable to the numbers that you want to put. After that, of course, you need to translate, to transform your whole data set into numbers. Is this clear or not? Okay. Now, if some of your data actually in one column, something like this one, yeah, a while ago, in one column consists of many values. So in this example, activities here, okay, in one column consists of many values. Can be one value, can be two values, can be three values, or four values like this. So in that case, you need to create for each value another variable. Okay, this is the technique. So for each value, you need to create another variable. So then you will create, because the total number of variable activities is 6, so then you create that 6 values. So and then the value now become binary. Is this clear? This is what I mean by coding. You need to code your data. Okay, until coding the data, can you do it or not?
Sir, I want to ask.
Oh, please.
So for coding the data, do we need to use Python or can we just use Excel, sir?
You can use Excel.
Excel only is okay. Or
Excel only is okay, but my question, do you have patience to do with Excel? If your data is only 10, yes, you can use Excel. If your data is only 1,000, yes, you can use Excel. Okay. If your data is 1 million, if you use Excel, you can. But every movement that you will do, it will take maybe 1 minute, 2 minutes. Do you have patience or not? You can use Excel, no problem. Okay. It will take a lot of time. Because, for example, if you want to do data analysis in Excel, it will take long time. For example, just to do one, you try, if you don't need to believe me, okay, you try by yourself, okay, you create your own data, 1 million rows, 100 variables, you just create a random, and then you put it into CSV, right? And then you open with Excel, and then you try to do data analysis. What will happen? Okay, then you will start to see that how slow Excel is, right? Super slow. And then after that, say you want to do slightly change, then you will wait for 5 minutes. Another analysis, then you will wait for 1 hour. So If you have patience, then it's okay, no problem with that. Okay, so for data, Excel is very good. Okay, but when your data is really very big, so then you start to see the problem. Okay.
Sir, so it means that we need to use Python, right?
No, it's up to you. Again, for example, if you think that oh, I can handle with Excel, it's still okay.
But another alternative is Python.
Another alternative is Python, R, MATLAB, whatever you want to use. Right.
Sorry to say this, but personally, I don't even know where to download Python, sir.
I will teach you later if you want. Okay. No,
Okay.
no need to worry about it now. Okay, if you want to download Python, first thing first, you download what is called Anaconda. Let me find Anaconda Python download. There. Oh, why it's so slow? Okay, I will put in the chat here. And there. Okay, you download Anaconda and then install that. That's the easiest way to get Python. And then inside that, you will have Python, you will have Spider, you will have Jupyter, the one that I just showed you. Okay. Okay. Next. Let's come back to the slide again. Okay, so suppose this is your data. Suppose you already get the data. Okay, this is the example of data is only 12, so this is very easy, right? So the next thing you need to do is to ask the research question. I call this research question. So basically you can ask, if this is business, you said this is a business question, right? So in this example, I will ask, in general, what is the level of visitor satisfaction toward the park of the city? What activity most people do in park? What mode most people use to go to park? So if you look at this 3 example of research question here, what does it mean? Okay. If you look at this, the actual things here is you are the one that I put in the red part here. Satisfaction, activity, mode. What is it? What is this? This is actually the variables. Can you see? Satisfaction, right? Mode, activities. Okay. So when you ask the research question, you ask the something about the variables. Okay. So here we are asking the level of visitor. We are asking about the most. Okay. And again, the most people. So we are asking the statistics of the variables. And if you look at this question number 4 to 6, is the existence of playground in the park making higher visitor satisfaction? Is there any relationship between activity and activity time? Is there any relationship between activity time and their mode to go to park? So what is this? This is 2 variables, right? The one in red is basically 2 variables. We want to get the relationship between 2 variables. Okay, so this is what I call as univariate. Okay, and this is bivariate. Okay, and by asking the research question about or business question about, you can focus only to answer those questions, and then you can ignore the other result. Okay. So again, the first step to do is to transform the data into another format that computer could understand. Okay. We are going to use Excel in here. So what you need to do is to convert the questionnaire data into numbers, one for each value. So this is the most important here. One for each value. Okay. So our concern here is the activity and playground, which is still not one for its value, right? You see here it consists of several values, and then playground still have text. So then we translate that, okay, into this kind of coded data. Okay. Once you can make this, then you can start to do data analysis. So in Excel, you have a data analysis tool, right? So you can have a toolbox, analysis toolbox. Do you want to practice this? Yes or no?
I think it would be better, so
Okay, let's
for us to understand.
let's practice that. So let me find the data. Where is the data? Data analysis from questionnaire. Maybe a statistic. Data analysis from questionnaire. Or you want to type the data? I need to get. Oh, there. I cannot remember where did I put that data that I put in this slide. If not, you can just type the data. It's only 12 data. Do you want to do that? Oh, here it is. Okay, I will upload this in Lentera.
Sir, for the group project, we can only use 12 data or we can use more than 12, yeah.
Of course, is the title of the course is Big Data, so you're supposed to get almost 1 million. Check the course syllabus, please.
So use Python, yeah, sir.
It's up to you to use Python or not.
Oh, for the variable,
For
how many variables should we?
please check the course syllabus again.
Oh, okay, sir. Thank you.
Right. I cannot remember. Can you check the course syllabus? How many? How many data?
Wait, sir, let me check it first.
Uh,
1 million data with 25 variables, sir.
minimum 25, right? So
Yes, yes.
yes. Okay. So if you refresh your Lentera, okay. So I put it there, the sample questionnaire data there, with only 12 rows. You can download. so that we can practice that. So the data will look like this. So this is when you open that, if you download. So the first sheet is about the description of variables, okay, family, and then time, mode, and so on. Okay, and this is the data. This is the data. Oh, I did not make the coded data. So first thing first, from the raw data, can you make the coded data? Okay, the first practice, okay, you go to sheet 3 and then you can copy this raw data, okay, and then you create the coded data. And then you share to me, some of you. Can you do that? The coded data is something like this. Is it possible? Anyone want to share the result of coded data? Did you download? And then you start to create the coded data. What's the meaning of coded data here? Meaning in one column, only one value, okay, not with comma. Okay. And then all the values are numbers, not yes and no. So which column you need to change? Only column activities and playground you need to change. The others are you just copy. Can you do that practice?
Sir, personally, I don't know how to separate the comments, sir. I don't know how to separate the comma.
You can separate the comma, okay, by creating what is called binary. Binary variables. Give example, 1, 2, 3, right? So you look at the maximum number of value there. So there are only 6 values, isn't it? Then you create new variables, okay, 1, 2, 3, 4, 5, 6. So these are the example. So this is how you separate the comma. Can you see that? So your first value is 1, 2, 3, right? So then 1, 2, 3 is 1, 1, 1. The others are 0. Do you get it? I think if you don't practice, you don't know. So
Sir,
hmm,
we have to separate the activity column like one by one manually, or there is also.
manually.
Oh, okay, sir. Thank you.
No, you create a new 6 column for activities, right? This can be, this is supposed to be done manually, isn't it? To create the columns. Okay, coding the data from text to numbers or from comma, yeah, to numbers. You need to do it manually. Of course, you can separate by in Excel if you want, but only 12 data, so you do it manually. If you have many, you can use text.
Sir, so we create like this first in our Excel, right?
Okay. You want to share your screen?
Oh,
Amira?
no, I haven't done it yet, sir.
Okay, so please do
Still
it.
processing.
can use this technique here if you want to use function. So this is semi-manual. Can you show that you have coded data? Okay, very good. Okay, so once you code the data, then you can start data analysis. Can you go to your data? Can you go to data? Oh, you have data analysis there on the right side. Right. That data analysis, okay. There. Then you can use the descriptive statistics. There, descriptive statistics, yes. Okay. So the input range is your coded data. No, from, yeah, including the name of the variables. Yeah. From families until the end. I think from second row. Yeah, until the end. Correct. And then, okay, label the first row, right? Okay, and then click OK. Then summary statistic you need to click. Okay, and then click OK. There you got that. Right. So you get so many numbers now. Correct? So you get so many numbers. So what are you going to do? If you have so many numbers like that, what are you going to do? What do you need to report? You don't need to report everything, okay? What you need to report is something that related to your research question. Okay, go back to the slide. Can you check what is the research question there? Can you answer 1, 2, 3? Research question 1, 2, and 3. Can you answer that using the one that you just analyzed? So it is important that you will see, okay, you can analyze the data easily, but to interpret, you need to have a guidance, right? The guidance is actually the research question that you supposed to ask in the beginning. Okay? Before you do data analysis, you need to ask research question. What do you want to know? So can you answer this question? In general, okay, what is the level of visitor satisfaction toward the park in the city? What activity most people do in the park and what mode most people use to go to park? Anyone can answer that after you analyze the data?
Is it satisfied, sir? Because the satisfactory level is 1 for the mean.
The satisfactory level is 1 for the mean. Okay, very good. What is the meaning of 1 there?
Satisfied.
Okay, satisfied. And then what else? Very good. That is number 1. Okay. And then what else? The second question is, what is the second question?
All the activity.
Yeah, what activities most people do in the park? So which number you will put there? That's the answer.
Number 2, sir.
Number
2.
2.
Picnic.
Which one? The mode or the
Sum.
I think it is car.
most
Because the mode.
majority? So when you said majority, then you use mode, right? So okay, so number 1 is mean satisfaction. That is mean, right? And then number 2 is actually mode, not mean. Okay. What do people, most people do? So that is not the mean, but the mode, right? How about the 3? Number 3. The question number 3 is, this is the mode, sorry. What activities most people do in the park? You get the frequency of this. Okay. You check the sum and then you get the frequency of these activities. Huh? Okay. So number 1, satisfaction, right? Satisfied, correct. Number 2, what mode most people use to go to park? Majority is number 2. That 2 mean cars, right? And then number 3, what activities most people do in the park? So you get this frequency and then you plot, okay? You plot the frequency relative and then you get the probability here, right? So you get the frequency divided by the sum of the frequency. That's the same as frequency relative. That frequency relative is the same as probability. Then you can plot. Okay. So here you can see majority doing what? Picnic and walking with the dog. Okay. So up to here, is there any question? You can do univariate variable, univariate data analysis, right? Meaning one variable data analysis. Is it clear? So the same for your group project, okay? You do similar like this. For each variable, you ask the question. What do you want to interpret?
Sir,
Yes.
so my group, but I'm not sure, but we want to do there is a Google App Store data.
Okay.
Google, so it is the data about Google Apps, and then the data is not not all numbers, right? But some texts are each different, such as like the emails of their developers are all
Okay.
different, right?
Okay.
So what should we do, sir?
Show me the data, then we can start to see.
Wait, sir.
Hmm.
It took a long time to open it.
You can cut, okay? Just show a few numbers of a few rows of the data. I need to know the variables. Or the metadata if you want to see. I want to know what is the variables and then what are the data type. A few examples, for example, 5 rows only is okay.
Okay, sir. Wait, still opening.
If your data is very big, then opening it takes a long time. Yeah? So to open, you probably, this is in text file, CSV. Is it?
Yes, CSV.
Okay.
I
So
think.
if to open that CSV, you probably use, you download Vim so that it will faster to open. If you use the normal text file or use Excel, probably if you have 1 million data, it will take 1 hour to open. You can download Vim, V-I-M. Let me check where it is. Vim for Windows. Vim for Windows. Okay. There. I will give you the link there in the chat. Okay. If you download Vim, that is faster.
Sir,
Hmm.
shall I share the
Yes.
screen?
Yes. Go. Open already.
Yes, it's like this.
Okay. So this is the app name. All numbers, right? Oh, you. So you can see here. Okay, there are some are numbers. There are some are, what is this? Date, right?
Yeah.
Okay. So the others are text. So this is interesting. So you can use this data. So how do you analyze this data?
Don't know, sir. I just downloaded it.
Okay. So again, for each data analysis, you can simply do univariate and bivariate analysis. Okay. So if your data is actually text, that is easier. So but the problem with Excel, if you use Excel, Excel does not allow you to use text in data analysis. If you use Python, that is easy to analyze this. So you can use this, for example, to do what is called frequency distribution. Okay, so how many are in your data? How many unique value in your data? For example, what is the range of the price? So if we look at the first, what is the app name, right? So how many is using certain apps? So you can check all the app names. Okay. Can you open this in actual Excel rather than in text like this? Do you know how?
No.
No? Okay, I will tell you how. So, uh, you go to Google, okay, and open text file or open CSV file in Excel. Okay, then you will see that open new Excel, navigate in the data tab. Where's the data tab? There. Okay, and then click from text button. In the data tab, is there any from text button? Can you see? I will share my screen. Huh? Okay, I will create a new one. I will close this and save. Oops, oh no. Okay, I will create a new. Okay, and then I will share this. So I create a new worksheet. Okay, and then go to data and then get external data here. And then from text. Okay, so for example, this is my data. Okay, this is in CSV or text. Huh? So I import. Okay, you will have a wizard here, and then you check delimited. Okay, and then my data has header, right? And then you go to the next. There you click comma, and then you go to the next. If you have date, okay, which one is date, right? So this one, you click the date, and then you put as date, okay, and then you click finish. Okay. Then you will get something like this. So this is in date already. Okay, can you try that for your data? Okay. So import. Can you open?
Wait, sir. I'm trying.
How about the others? Can you finish? The, Josephine is trying. So, do you want to show your coded data, your analysis for the questionnaire data a while ago? Okay. When I said univariate data analysis, that means you analyze a single variable, yeah, one variable. for each one variable, so you analyze. So in Excel, you can use descriptive statistics. That is one of the simplest way, right? So if you have your group project data, you can also start to ask, and we can also do a univariate data analysis. Is there any question? So I'll break for 10 minutes. It's almost 10. So, okay, so once you have created the univariate data analysis, meaning you deal with one variable, you can also deal with two variables or more, right? So one technique, if you want to use this in Excel, is to use pivot table. Have you ever used pivot table before? Yes or no? No? Okay. Okay, let's do that in Excel. So you have your formatted data, right? So where is it? I will share my screen here. So you have your formatted data here, right? So what you need to do is to go to Insert. So there is a pivot table, right? So you go to pivot table, and first you select the range. Of course, you select this as your range. Okay. And then say you go to a new worksheet. Okay. And then click OK. There. So you have a new worksheet, sheet 1, for example. This is the pivot table. Now you can drag and drop, okay, the thing that you want to put here. So the one that you drag and drop depends on the research question a while ago, right? What is the research question there? The research question number 4. Let me check what is the research question number 4. Is the existence of children playground in the park making higher visitor satisfaction? So we want to know, okay, playground and satisfaction, right? So if you want to know the playground and satisfaction, what you will do? So you put the satisfaction in the row and playground in the column, and then you put the count of satisfaction, right? So what you will do, you put the satisfaction. Where is the satisfaction? Satisfaction here, I put in the row, and then playground in the column. Okay, and then you put the satisfaction in the values. Okay, but if you do that, okay, you will have only the sum of satisfaction. I don't want to know the sum, so we change this field value. Instead of sum, you get the count there. So you get the result, okay, of how many uh, people said, oh, you can see here, if no playground, okay, mostly -1 or 0 or 2, right? If have playground, 2 and 5. So you can see from this result, actually, have playground is actually better than no playground, isn't it? Can you do a pivot table and then you share with me what you got? Any of you? If you have problem, you tell me so that we can solve it. First thing first, you need to open your video so that I will know that you're there. Right? Always, right? Remember in the course syllabus, I said if you want to do it online, you need to be on for the video. Okay. During the class, you need to turn it on. And then, if you have problems, so you tell me so that we can solve it together. Ken Jordan, where are you now? Which analysis are you doing?
I'm still looking at my data set, sir, with my group, actually.
Oh, okay, for the group project.
Yeah.
Okay. Netanya,
Yes,
where are you now?
I'm still trying.
Did you do the pivot table?
Still trying.
Okay, okay. Stephanie, are you there?
Sorry, sir. My internet actually really unstable. So if I open my camera, it will disturb me, sir.
Hmm. So, can you share your screen, Axel?
Oh, my screen. Wait.
Where are you now in the data analysis?
I'm still trying, sir, but I can't.
What I mean is,
so
what are you trying?
I'm still calculating actually rear, but I already closed the Excel, sir. I'm doing it on another one, not this one.
Not this one, not the questionnaire.
Yes. Sorry.
Did you do the questionnaire data here? For example,
Uh,
the coded, the formatted data a while ago?
Earlier, but I think I already closed it but, and didn't save it, sir.
Okay. So you cannot show any result.
Yes, sir. I'm still trying, so I don't have the answer.
Okay. Jonathan, you want to share your screen? What are you trying to do? And thank you, Arsen.
I'm still same like Excel, sir.
Oh, you have any difficulty?
Not yet. I'm still doing the table first, practicing the table.
Which table?
The first one.
Okay.
Sir, I'm a little bit confused about the pivot table. Can I share my screen?
Oh, of course. Carry on.
Okay, sir.
Okay,
So this one, sir.
okay, before this,
Okay.
why the row table is like, okay, can we go back to the actual data?
This one, sir.
Okay. Okay. Let's start from here. So you go to insert
Yes.
and go to pivot table.
Pivot
Pivot table,
sir.
not pivot chart. Pivot
Oh,
table in the on the left side, in the left. Let me get annotate this one.
oh, yes, sir.
Okay. Right. So select the pivot table. Where do you select?
This one.
Yes.
Everything.
Okay, and then you
Okay.
okay. Click OK. There. Then you can click any variable that you want. For example, satisfaction with playground
This function and the row.
in the row. Right. And then playground in the column. Okay. And then say satisfaction again in the values.
Satisfaction.
In the values. Now you change that value. You click this sum of satisfaction.
Yes, sir.
Right click. Oh, field setting. There, you change to count. Click OK. There.
Oh,
Oh,
okay, sir. Thank you a
okay.
lot, sir.
Yes. So everyone clear something like this, similar? Okay. Should I continue or should I wait for you? Say you want to know variable playground has relationship with satisfaction or not, right? That's what you want to know. So one way to do is called a chi-square test. Okay. So if the result of chi-square test show that the variable playground, yeah, actually independent from the variable satisfaction, then we cannot conclude any relationship between the two variables. Okay. Otherwise, we conclude the relationship between the two variables. So this is the simplest way to calculate whether there is a relationship between two variables. Okay. So the step in chi-square test is as follows. So first, you have the what is called observation table. Okay. Next, you count the independent values. Okay. And then you compute the chi-square and the degree of freedom. And then you decide the significant level and then compute the chi-square probability and decide the relationship. So let's do it one by one. So first you have the observation table, right? A while ago that you did using the count of satisfaction and playground. Okay. And then step 2 is to count the independent values. So how to calculate the independent value is as follows. Okay. To get the cell of independent table, you need to multiply, okay, the total rows with the total columns and then divide with the total data. So in the grand total here, this is the total of the rows, and then the grand total at the bottom is 5 and 7. This is the total of each column, right? So then you create a new table to get the independent count. Okay. So independent count, the formula is something like this, the website. So if you look at the formula, it looks like complicated, but actually this is simple. Okay. So for each of this cell, you calculate the sum of row multiplied by the sum of column divided by the total of all data. So in this example, in this cell, for example, 2.33, where it come from 4 multiplied by 7 divided by 12. Okay. 4 is the total rows, 7 is the total column, and then 12 is the total all. Yeah, you do for all of those cells. So in my example, what is that? So you have this formatted data, and then you have the seed 1, right? So you already did the pivot table. Okay, so to calculate, I will copy this all, and then I put here, and then I do paste value. Okay, why I need to put paste value? So that you can calculate. If you use the pivot table here, you cannot calculate well. So this is the one that we will use. Okay, these all values. So I format this so that you can see well. Okay. So we have the count of satisfaction. So I will copy this. Here I need to get the independent. Yeah. Now I get the independent count. Independent count. Yeah. So to get the independent count, let me put this. The width is probably 4. Okay, so that you can see. So to get the independent count, what I will do is to get the row multiplied by the column, the sum of the row multiplied by the sum of column divided by the grand total. Okay. Now I want to copy everything. So the one one that in I need to anchor, okay, the column will not change. The one in the bottom, I will anchor, the row will not change, right? The grand total, I will anchor both, okay? The row and the column will not change, okay? Then you copy this to all the cells, okay? So this is the one that you change. Okay, what does it mean? So I will put 6. So if this is independent, okay, these are the values. Okay? If this table, count of satisfaction, is independent, these are the values supposed to be, right? So you get the count of satisfaction and you get the independent count. Then next is to calculate the chi-square. Okay, to calculate the chi-square, this is the formula. Okay, so you get the difference between the observed value, which is from the pivot table, and the expected value, which is from the independent table. And then you square this difference, okay, and then you divide with the expected value, okay, so that the unit will go back to the original value. So, and then you sum for all the entire table. Okay, so remember, this double sum in sum of all the table. So we create a new table. We call this chi-square table, okay, with this observation minus the expected, square it, and then divided by the expected. Okay, so let's do it in Excel. So I create a new table here. I copy this. Okay, and then I call this chi-square. Chi-square. What is the formula in chi-square? So I need to change these values here. Okay. What is the formula of chi-square? The observation minus the independent. Okay. And then you square this, and then you divide with the independent. Okay, there. That. Right. So this is the independent. So of course this is the sum. This one. And this is the sum of the above. There, you get that the actual value here of the chi-square. This is the actual chi-square. Okay, so this is not equal. So this is the actual chi-square. Yeah? The chi-square value is the sum, all of this. Okay, so I will put sum of all of this, which is 7.88. Okay, so you get the value of the chi-square, which is 7.886. Okay. Then next one is to calculate what is called degree of freedom, okay, and the probability, right? So I'll share my screen. Okay, you get something like this. First is the count of satisfaction, which is from the pivot table, and then you get the independent count, which is just the grand total of the row multiplied calculate the chi-square table, which is the observation minus the independent, square it, and then divide it by the independent. Okay. Next is to calculate the DF, degree of freedom. What is degree of freedom? Okay. Degree of freedom is the maximum number of quantities that are free to vary given the statistics. Okay, that is the definition of degree of freedom. So in here, because you have a table, so degree of freedom represented by the total rows minus 1 multiplied by the total columns minus 1. Okay, so to understand degree of freedoms, okay, let me show you an Excel. Okay, I will create a new sheet here. In Excel, I will create a new sheet. Okay. Say I have any number, so I will create any numbers here. And then say I put 1, 2, 3, 4. What is the sum? 1, 2, 3, 4. What is the sum? 10, right? So this is the sum. Okay, and what is the mean? So average, this one, right? So sum, mean, standard deviation, mode, median, these are all called statistics, right? So these are the data. Okay, data is 1, 2, 3, 4. The question is this: how many data that I can delete? Okay, knowing the sum or the mean. Okay, how many data I can delete that I can get back the data? Look at this. Okay, I copy this, the sum. Okay, I copy and paste as value. Oops. Okay, which is 10 and 2.5, right? So now I deleted this last data. Okay, one data I deleted. Now the sum is 6 and the mean is 2. So if one data is deleted, and I know the original sum is actually 10 and 2.5 for the mean, right? Can I recover this data that is missing? Yes or no? What this data should be so that I can recover that the sum is actually 10. Okay, forget about the mean so that you are not confused. Okay. What data I should put in here in F3 so that the sum will be 10? Anyone tell me? 4. Yes. Okay, so if I put 4 in here, oh, I go back. The sum is 10 and the mean is 2.4, 2.5. This is correct. So I can delete one data, right? And I can recover the statistics. How about if I have two data that I miss in here? Can I recover the original sum, which is 10? Which data should I fill in here so that I can recover the statistics? A while ago, you can recover easily, right? How do you get 4, Josephine? Which is 10 minus all of this data, right? Correct? So that's why you get the 4 in here. But if you deleted 2 data, you cannot recover, right? Because you don't know how to get that 2 data. So the only things you can recover is only if you miss only 1 data. So that means the degree of freedom of one row of data like this is 1. Why? Because 1 is the only number of data that you can delete and recover. 2 missing data you cannot recover. Only 1 missing data you can recover, right? But if it is a table, okay, say 2 by 3 like this. This is your table. Okay, so I will call it A, B, C, and D, E. Right? Now I know the sum. Right? If I know the sum, and I know the sum at the bottom, say I have a data simple 1, 2, 3, 4, 5, 6, right? So the sum is already known, so I will copy this sum here so that it will, will not change this, right? And then I will copy this sum here at the bottom so that you know what is the actual value. Okay. Now if I deleted 1, can I recover? Yes. If I deleted 2, can I recover? Yes. So the degree of freedom in here is actually the number of rows, okay, minus 1 multiplied by the number of columns minus 1. Okay, the number of rows is how many? 3, right? 3 minus 1 is 2. How about the column? Column is 2 minus 1 is 1. So then the DF in here is 2 multiplied by 1, which is 2. So you can, if you delete 2 values, either one, so for example, this one and this one I delete, you can still recover back. Okay, you will know the actual value in the data given the statistic that the actual value is this one. Right? The actual value is this one, the one in blue. Right? For example, the actual value is 11 here. This is 5. So what you will do? You will change this to 6, right? Easily. Yeah. How about this? What is the value here? We know that the actual value should be 12. Okay, but this is 10, so this must be 2. Right? You see? So that's the meaning of DF, yeah? Degree of freedom. Okay? What again? Degree of freedom. The maximum number of quantities in the data that are free to vary. So you can delete that data and you can recover back. Okay, given the statistic. Do you understand the meaning of degree of freedom now? Okay. So for your table a while ago, how many rows and how many columns? Anyone? So we have 4 rows, right? 1, 2, 3, 4. And then how many columns? 2 columns. So 4 minus 1 is 3. 2 minus 1 is 1. So 3 times 1 is 3. So the DF is 3. Right? Oh, until here first, until DF. Is there any question? Karin, do you understand?
I'm trying to follow up, sir.
Okay, you
And
tell me. Would you tell me
sir,
what you understand so that I can start to understand you?
itu sir, actually I'm also searching for my group project. I want to ask sir. So if my group project decide to use maybe like a unnamed review, is it okay, sir? Can I show you maybe
And yeah,
the
okay.
data? Okay, sir. But let
So,
me share my
yeah.
screen.
Okay, so
Yeah, is it
data.
like this, sir?
Hmm. So you see here in the score, you have how many values there? 1, 2, 3, right? This is okay. This is good, right?
Okay, yes, sir.
Yes. 1, 2, 3, 4, 5, 6. Your data is, how many data do you have?
A lot, sir.
A lot. Okay.
Like this.
Okay. Well, not so big. The data is not so big.
200 many gitu, sir.
Okay.
Megabyte. Yes.
So you can separate this ID later on, huh?
Yes.
ID is unique, right? So you can separate the ID because everything else except the ID is the same, right? So then you can separate this into new column. Okay, you create an ID
Oh, okay, sir.
to analyze that data, right? This is
Yes.
also, and then for the score, you need to separate them, right? So for overall, stories, animation, sound, character, enjoyment, those are different columns later on, huh?
Yes, yes.
Yes, okay.
So it is okay, sir.
Yeah,
to
it's
use this
okay,
one.
but your number of data is not okay.
Oh, is it too little, sir? Or too much?
Too little.
Too little.
200,000 is too little.
220 megabyte, I think. In your PPT, you said more than 100, right, sir? So this one is 200 something.
Okay, so it's satisfy the criteria of the.
Yes. Yes, sir.
Okay, so if you can satisfy the criteria, then it's fine. No problem.
Oh, okay. Okay, sir.
Okay.
Okay, okay.
So you can use this data, no problem. So
Okay.
next, can you analyze?
Yeah, I'm trying to figure it out, sir, maybe. How to analyze the data.
How to analyze the data is the same, okay? The technique is always the same. So first you need to code this.
Oh, I'm sorry, sir.
You need to code, meaning
Oh, yeah.
you need to create the columns, separate all this data.
Yes, just like you teach us before, yeah, the coded data.
Yes, and then now you separate for example, the link in here, you need to separate the ID into new columns. So you derive new columns,
Yes.
okay?
Okay, sir.
So, good.
Okay, sir. Thank you.
Anyone else? A problem? How about the chi-square? Can you do it?
You are asking me, sir?
And anyone? Yeah.
Oh, okay.
How about you, Karin? Can you do the chi-square?
Oh, wait, sir. I'm still trying, sir.
Distracted with the group project, right?
Yes, sir.
Anyone have done the chi-square? Janice?
Not yet, sir.
Said Amira? Probably.
Still trying.
Or Josephine? Not yet. Okay. Okay, so I think there is no point to continue this data analysis from questionnaire if you are not ready yet for this. I will continue later on, maybe in the next lesson. Maybe next week is okay in that case. So tell me what you are trying to do so that I can help you.
So, sir, before like I show you my data set from the anim review, right, sir? So from that one, we need to decide what variable we want to analyze here. I
Yes.
think.
First, you want to show again. I think it's very clear already, the data that you.
Oh, yes, sir. Actually, I'm still a bit confused, sir, on how to analyze
Okay.
this one.
So you have UID, meaning user ID, right?
Yes, yes, sir.
So and then this is the profile, right? This is one data. The text, I don't know why you lost it. And then
Oh yeah, yes, sir.
so you need to get the score. You can also separate this. Can you separate this? The score.
The score.
Hmm.
Oh, this one or
Yeah,
this
that one.
one? Oh, this
Column
one.
F.
Oh yeah, yeah, yeah.
Can you
So
separate that? New columns for overall, for stories, animation, sound, character, deployment. You separate that.
yes, yes.
Link,
Yes,
can you get the ID only from the link?
for the link, I'm not sure, sir. How to separate it, yeah?
Oh,
What
very
do you
easy. You go to the column, say you go to column K.
Column K, yes.
Okay, column K2.
K2, yes.
Okay, and then equal.
Equal.
And then right. Okay, and then open the what is that?
Bracket, sir.
Bracket. Open bracket. Okay, and then go to column G.
This one. G. Oh,
G.
this one.
Okay, comma,
Yes.
len, Len, L-E,
Len.
yes.
Oh, close this one.
Oh, wait.
Oh, not yet. Sorry, sorry.
Oh, that. Okay. Maybe in column K, you just put equal, fine first. Equal,
Fine.
fine, open bracket, quote. Okay, quote, equal.
Quote equal.
Yes. Something like this. Quote, equal, quote. And then comma, and then
Oh,
column.
good, sir. Wait, where is the zoom, yeah? Sir. Quote equal quote. Quote equal quote, and then comma, sir. Yes.
And then within text, that means G, column G.
Oh,
And then close it.
39.
That 39 mean what? That means equal is in the column 39 of that text. So now,
Oh, yeah.
okay, now in column L,
Yes, sir.
so you put right, equal, right
Yes.
off, open,
Bracket.
yes, and then column G, okay, and then comma, len of column G, Len, open,
Bracket.
len
Column
of column
okay.
G, close it, minus K2.
Minus K2. This one, sir.
Is that correct? Okay, close it.
Oh. Oh, yeah, sir.
So you copy that to column K and L down.
Oh.
No.
Column.
K and L,
Yes.
you copy down so that you can get.
Like this.
Yes, and then the other one also.
Like this, sir.
Oh, you get all the ID.
Yes.
Yes.
Oh, okay. So from the link, we can analyze these two, yes, sir. The equal sign and the...
Actually, column K is not needed, right? I'm just showing.
Oh, okay. Okay, sir. Oh, not needed. Oh, yeah. So, okay.
I'm just showing the way to do it so that you will know how it works. Right? So the
Yes, yes.
score, you can do the same thing, you know.
For the score,
The
this one
score.
or this one,
That's,
sir?
yeah, that F. You can separate them, right?
Yes, yes.
You can get the overall, you can get the story, and so on.
Animation.
Yes.
Oh, okay, sir.
Okay.
Yes, yes, yes.
After
And for,
that,
yes,
once
sir?
you do that, once you create the clean table of
Mm-hmm.
data,
Yes,
this is raw data, right? So you need
yes.
this into a
Coded data.
is the only data, okay? And then you can start to analyze. So univariate, bivariate, and so on. Yeah?
Oh, yes, sir. So for the anim ID, this one user ID,
Again,
what can we do? What can we do about it, yes, sir?
again, you can use frequency distribution of this.
Frequency distribution.
Okay, first thing first, what is the data type here? Anim ID is this, what is this number mean? Binary, categorical, or numerical?
Is it, wait, sir, is it numerical, yeah?
No, this is
Oh,
not
no,
numerical. This is ID is always nominal data. That's category.
Yeah, sir.
How about the score here?
Oh, score is, should be numerical, yeah, I think. No, categorical. I don't know, sir. I'm confused.
Did you learn about ordinal, nominal, interval, and ratio data type?
I think we got ordinal, nominal, wait, sir, ordinal, nominal, ratio, and what, sir?
Interval.
I think we learned ordinal and nominal, sir, in semester 2, I guess, in
Okay.
mathematics.
So what is this data?
Oh, ordinal should be the one that can be ordered, right, sir? So
Right.
supposed to be score is ordinal, right?
Right.
Yeah, right?
Right.
Yeah, okay.
Column F is also ordinal, right?
Yes, sir.
So how about ID? ID is ordinal, nominal, interval, ratio.
I think ID will not be ordinal, right?
What is ID? What is the data type of ID?
Wait, sir, I forget about interval and ratio.
Okay, no problem. So let's discuss about it in that case if you forgot, okay?
Okay, sir.
So
Should I stop my share screen, sir?
yeah, I will
Okay.
screen that case. So you go to Elentera, we have exploratory data analysis. Okay, in Lentera, you can see exploratory data analysis, this slide. Can you see it? No, not yet?
We can, sir.
Can you download the slide so that you can follow? So in this slide, we will discuss about three things, okay? Characteristic of data, measurement of scale, and data exploration. Okay, so what is data? Data is collection of objects and their attribute. So this is important to know the other name. So when we say object, it's basically the rows. So this example of data, okay, when we say attribute, is basically the variables. Okay, so when we say attribute, we say variables, field, characteristic, features. All these names representing the same things, which is the attribute or the variables. How about the row? Other name for rows is object, record, point, case, sample, entity, instance. All of these name, okay, basically talking about the row. Okay, this name here is representing the rows. All this name here representing the variables. Yeah? So the data usually is in the form of table. So these other variables, each variable is one column, right? And then each object or each row represent one record. Okay. Next, actually, the one that we just showed a while ago is called data table or record. Okay. So we can also have different type of data. Okay. So for example, these are the data representation can be a data matrix, right? The crosstab table a while ago that we discussed. You can also have what is called text document data, okay? And then we can create what is called term frequency vector. Okay? If you have a text, we can check the term and then the frequency. The term is the word, okay? And then we can also have what is called transaction data. This is example of transaction data. Okay, this is transaction ID, right? In one transaction, what they buy bread, they buy Coke, they buy milk, right? This is transaction data. We also have what is called graph data, okay, and order data based on the spatial, temporal, or spatio-temporal, okay? And data can be put into matrix, vector, or actually the scalar. And data can also put into vector, set, list, and tuple. So I will discuss what are the difference. Okay. So these are the example of record data. Consists of rows and column. So data that consists of collection of rows, each of which consists of a fixed set of attribute. This is called record data. Look at the data type here. Okay, this is binary refund. Okay, whether last year there is a refund in the tax. Marital status is nominal, categorical, right? And taxable income is numerical. And whether they will cheat or not, okay, this is again binary. Okay, the data type is very important for data analysis, so you need to know. How about data matrix? Data matrix, okay, is the data object that have the same fixed set of attribute of the same type, okay, but not both. So can be categorical or numerical, but not both sides. Okay, so example here. Okay, this is the data matrix. Okay, all numerical, right? So in each column of the matrix represent one variable, the same like data table. Okay. But in data table, you can mix between different data type. But in data matrix, you only have one data type, either text, okay, categorical, or numerical. Okay, and if you handle text, okay, you have what is called document data. So in this case, you will create what is called term vector. This is the example. Okay, say if you have a document data, for each document, you put it in the row, and then you create the term. The term is the word. Okay, so for example, the word team, the word coach, the word play, yeah, and so on. So, and then what is this? How many times this represent the count? Okay, how many times team, the word teams in the document number 1? How many times the word teams in document number 2, and so on. So this is called term vector. Do you get it or not? So because text is categorical, nominal, so all you need to do is to do what is called frequency. How many times it happened? Okay. Now, if you have transaction data like this, okay, So this is set. Each record represent the set of items. Okay, we don't care how many bread, we don't care how many coke. Okay, we only want to know whether the bread and the coke goes together. Okay, whether the beer and coke and diaper and milk goes together. So this is called transaction data. Okay, so it's a set. You understand the meaning of set? Set means they are unique. Okay, so for example, bread and bread and bread and bread will become one bread if they are the same bread. Oh, how about if you have a transaction of bread type A and bread type B, and then bread type B again? So for each type of bread, you will represent it as unique value. Okay. So graph data, this is a HTML link, for example, the one that you showed a while ago. Okay. So you will have graph data, and then there's a link between one page and the others, right? So then you can represent that as a graph. One node in here represents one page. So in one page, there are several links, right? So how do you know the link? You check the HTML, and you will see the href. Okay, these are every time you see the href code, that represent the link to other page, right? So then you can start to draw, okay, one page go to other page. So graph data. Okay, similarly, if you are dealing with chemical, you have graph data. Okay, if you have a transaction that is in order, say for example, A represent the Coke, B represent the diaper, for example, and so on. So you can also use sequence of the transaction, okay, that they are going together in one sequence. So what is this called? Another type of data is genome. So this is the DNA. Okay, it's very long sequence of 4 types with this G, T, C, and A. Yeah. So this is another data type. And data, you can also use space and time. So this is the example of space and time data that we plot. So you see there are different time, different month in here, and then the space is location. Yeah. A while ago, the accident data, I also show you the space and time that we can analyze. Okay. Next, data can be represented as scalar or vector. Okay. Scalar mean numbers, right? Vector is n-dimensional numbers. Okay. So vector has value and direction, right? So we can represent that vector as an arrow. So you have the angle here represent the direction, and you have the origin. Okay, and this is the vector. The length of the vector, okay, represent the value. Okay, so vector is basically a set of number, for example, 2, 3, 4. Okay, this n-dimensional number can be represented as arrow in n-dimensional space. Okay, so and then if you use vector, you can put those vector, okay, with the matrix to transform the matrix into something else. Okay, so this is an example of rotation matrix. So if you have a data coordinate of x, y, okay, you multiply by this rotation matrix, you will get another data which is rotated. Okay, so this is an example. If you have a data like this. This is supposed to be your data. Okay. And then you get the mean, which is the average of each column, right? And then you minus the data with the average. What is the purpose of you minus the data with the average? That is to translate to the mean. Okay. And then from there, you start to create the data which is already have the mean of the origin. From there, you can use the rotation matrix so that you can rotate the data. See? So you multiply this, okay, to get a new coordinate. Okay. So for example, before rotation, this is your data. Okay. After the rotation, this is your data. Do you want to practice this or you just want to skip this? If you don't want to practice this now, you can practice this at home, or I can give you this as assignment so that you can practice to create something like this. So what do you think? Give me your feedback. Hello, are you still there? Okay, I will give this as assignment then. Okay, so that we can continue with the lecture. So, except for the vector, okay, vector must be numbers, right? All the other data here is not necessarily numeric, so it can be string, text, right, or object. So we have what is called tuple, and we have what is called set. Okay, what is tuple? Tuple is a record of unique object in the sequence. What is set? Set is a list of unique object. Okay, not necessarily in the sequence. So in tuple, you need to have the sequence and unique object. How about vector? Vector is basically ordered list. That means non-unique object in the sequence. So if you see here, we have whether they are unique or not, right? So unique, okay, and then not unique. Okay? So data can be unique or not unique. And then next is in sequence or not sequence. Yeah? The same thing, sequence or not sequence, right? So unique means no repetition, right? So sequential means the order is important. Okay, so then now you can see here, okay, there are 4 types of data in the sequence. So one is if the data is in sequence means, for example, this one example, 1, 2, 3, 1, 4, 3. Okay, you cannot reverse the sequence. Okay, 1 must be first, and then 2, and then 3, right? And then 1 again, and then 4, and then 3. So the sequence matter in this vector, right? So the same thing with the tuple here. Okay, 3, 4, 6, 1, 7. That sequence matter. But the difference between vector and tuple is this: in vector, okay, the repetition is allowed. Okay, in tuple, the repetition is not allowed. You see here, 1 and 1 is repeated, right? 3 and 3 is repeated. But in tuple, you cannot repeat. Next, we have what is called unordered list and set. Set means you have unique and the order is not important. Okay, so you have a unique sequence, okay, which is the order of the sequence is not important. So if you said 3, 4, 6, 1, 7, right? I can reverse the order like this. So 1, 3, 4, 6, 7, they are the same set. Okay, the order is not important in a set, but they must be unique. So how about unordered list? Unordered list, okay, similar to set, but you can repeat. For example, 1 and 1 in here is repeated, right? 2 is not repeated, but what is this? 3 is repeated, right? So because order is not important, you can have this 1, 2, 3, 1, 4, 3 that is equal to 1, 1, 2, 3, 3, 4. Okay, you can sort it and they are actually the same meaning. Okay, until here, can you distinguish between sequence and order? Can you distinguish between unique and repetition? Can you distinguish between vector, tuple, unordered list, and set? Give me feedback. This is just name. I just want to introduce you with the terminology. Can you distinguish those? If not, you can ask question. Saint Patrick, what do you think?
Regarding what, sir?
Can you distinguish set and vector?
Basically, I'm still trying to like absorb what you have just explained for us. So I'm still absorbing what you are talking about.
Okay, what is set?
I'm sorry, may I please see the slide, sir?
Oh, you have the slide in Lentera. You did not download it yet?
Yeah, I'm seeing it in Lantera, but I'm confused which slide is it right now.
The exploratory data analysis.
Yeah.
So what is set?
Wait, sir. Oh, this one. I just want. So basically, from what based on my understanding, set is like a collection of like maybe the object, but the order or in this case is sequence is not that important. That's from my understanding.
And one more thing, one characteristic, very important characteristic of set is unique value.
Unique value.
Okay, so the order is not important and then it has unique values. Okay, for example, if you have A, B, C, if you put it into set, it will become only A, B, C. The repeated A will not be counted. Right?
Yes,
Okay, so important of set is it has unique values. Okay, well in vector, the value are not unique, but the order is important. For example, in vector 1, 2, 3, right? You cannot change it into 2, 3, 1. They have different meaning. But in set, 1, 2, 3 is the same as 2, 3, 1. because order not important in set, but in vector, order is important. Clear?
Yes, sir.
Very good. So, okay, so you have learned about the attribute and data. How about this? See, data can be represented as attribute and value. So what is attribute? What is values in there? In this data, what is attribute? Example, okay. In this data, what are the attributes in this data? Hmm? Can you see it? I cannot see your chart. What are the attributes in this data? Can you see my slide?
Yes, sir.
What are the attributes in this data?
The marital status,
Mm-hmm.
refund,
Refund to
it,
cheat and then taxable.
yes.
Right? Okay. How about the ID? Is it included in the attribute or not? Is ID included in the attribute? Yes or no?
No, I think.
Yes. Okay. So how about the object? Huh? How many objects in this data?
10.
10. Okay. What are the value of refund? What are the values of refund? The value of refund is either yes or no, right? So there are two values. What are the values for marital status here?
Single, married, or divorced.
Very good, very good. Okay, so taxable income is numerical, so not necessarily unique value, right? So they are values of numerical. How about the value of cheat?
Yes or no.
Yeah, it's a binary type. Okay, very good. So can you distinguish between attribute, variables, and values? Okay, so data can be represented as attribute and values. Okay. Next, the values, okay, the attribute values are the number or symbol that assign to the attribute. Okay, you need to distinguish between the attribute and attribute values. Okay, so the same attribute can be mapped to different attribute values. For example, the height, right? The height can be measured in feet or meters. Okay? The values are different, but actually they are the same height. Okay? Now, the different attribute can be mapped to the same set of values. Example, okay? The attribute value for ID and age are integer. So they probably the same value. The ID is 50, the age is 50. They are both integer, the same value, okay, but they have different meaning, right? That 50 in ID is ID number nominal, right? The 50 in age, that is actually numerical values of the age, right? So the properties of the attribute values can be different, okay? So the ID have no limit, but the age have maximum and minimum value, okay? Now, very important that you can classify, okay, how they are categorized, counted, or measured. So in this case, you need to know the type of the attribute or data type. Okay, the data type can be two, either qualitative or quantitative. Qualitative data type is nominal, ordinal. Okay. Quantitative data type is either interval or ratio. So you need to distinguish between nominal, ordinal, interval, and ratio. Okay. So next week, in the beginning of our meeting, you will have a quiz about this. Okay. Just one or two problems that you need to solve. Okay. You need to come on time. So qualitative data is a data that can be placed into distinct categories. Okay? Sometimes can be arrayed into meaningful order, but no arithmetic operation can be applied to qualitative data. Okay? You cannot add, you cannot minus, right? You cannot multiply, you cannot divide. Okay? For example, ID. Okay. Like user ID a while ago is qualitative data, right? So blood type of a person is qualitative data. Assignment of evaluation, for example, fail, pass, good, or excellent are qualitative data. Text are qualitative data. Okay? So qualitative data can be numeric quantitative data are numeric in nature. Okay? Quantitative here. Quantitative data are numeric in nature. They can be ranked in order, okay, and they also admit to have meaningful arithmetic operation. In this case, can be classified into discrete or continuous. Okay, so what is discrete data? Discrete data is the data that whose value can be counted. Okay, so that means you can represent it as integer, right? So the data cannot assume all values on the number line within the value of range. So it has only limited, finite, or countable, infinite set of values. Okay, so any data that can be represented as integer variables are discrete data. Okay, so for example, binary are also discrete data. Okay? Zip code, okay? The frequency, the count, okay? The set of word in the document, the number of children in the family are discrete data. Yeah? The number of cars that you have are discrete data. Continuous data, okay? You need to map data into real number, real number. So if you can map the data into real number, then this is called continuous data. Okay, for example, temperature, height, weight, and so on. Okay, so usually continuous data are ratio type. Okay, so we have 4 measurement of scale: nominal, ordinal, interval, and ratio. Okay, what are the difference? Okay, so nominal, sometimes we call it categorical data. So it has existence of the choice without any order. Example, gender, okay, is the nominal data, either male or female. You can put male as 1, female as 2, or the other way around. You can put female as 1, male as 2. It doesn't matter the order. Okay. In fact, 1, 2 is just mapping representation of the data that you assign. Number 2 is ordinal data. Okay. So sometimes we call it order, sometimes we call it index. Okay. So index is basically ordinal data. So what is the characteristic? It has sequence. It has order of choice. For example, from hot hotter until hottest. Okay, there is a scale, there is an order, there is of course there is existence of choice, there is order. Okay, so in nominal level of measurement scale, you can put into mutually exclusive or exhaustive. Okay, mutually exclusive mean non-overlapping. Exhaustive mean you need to list all the categories. Okay, in nominal data, you cannot make order or ranking. Okay, there is no ranking in nominal data. So these are the example of nominal data. The fruit that I like, okay, the variable name is fruits. The fruit that I like is apple, banana, orange. So you can assign any numbers to this value. Okay, for example, I put 1, 2, 3. Okay, 1 for apple, 2 for banana, 3 for orange. But you can put any numbers. For example, I can put -1 as orange, 0 as apple, +1 as banana. It's up to you to assign the numbers. Okay, the number is only symbol, as it has no meaningful value aside from the mapping. Okay, the same thing here. Gender is nominal variable, right? The value can be 1 male, 2 female, but you can change and reverse the order. For example, I can name it female is 5, okay, male is 225. As it is valid, okay, valid of mapping as long as it's consistent with your definition. Is it clear? Okay, next is ordinal data. So ordinal data has category that it can be ranked. Okay, you cannot take difference. Okay, there is no arithmetic that you can use here. Okay, for example, rank 2 and rank 5, what's the difference? There is nothing. Yeah, 5 minus 2 is 3. Does not mean that the difference is rank 3, right? So these are example of ordinal variables. Index. Okay, so -2 strongly disagree until 2 strongly agree. Okay, Likert scale here is called ordinal variable. Or you can use rating. Rating 1 is very dissatisfied. 100 means satisfied. So your grade, okay, in exam are basically rating, right? 0 to 100. Or you can use rank. Rank of priority. 1 means rank best. The higher value have lower importance. Or you can use ordering. Okay, sequence of label based on rank. So what's the difference between ordering and rank? So this is an example. My preference of fruit factor is grape, mangoes, banana, apple, and orange. Okay, so that is given, right? Grape, mangoes, banana, apple, and orange. So now, if you said ordering, mangoes is ordering 1, orange is 2, banana is 3, apple 4, grape is 5, right? So now my rank factor is 5, 1, 3, 4, 2, okay, which is based on the preference. So this is given. Okay, so for example, I like grape is 5, right? Mangoes is 1 and so on. So this is based on the preference. Then my ordering factor is actually mangoes, orange, banana, apple, and grape. That is based on the sequence of the rank. Okay. Next is quantitative data, which is interval and ratio, right? So in interval, you can do plus and minus, but you cannot multiply, you cannot divide. In ratio data type, you can have 0. That means you can multiply and divide. Okay, so interval measurement of scale Okay, you can take the difference, but there is no zero. That means zero mean nothing. Zero mean null. Nothing there. Okay. Example, Fahrenheit temperature. Okay, it has meaningful difference of 1 degree between each unit, but 0 Fahrenheit does not mean there is no heat. Okay. 74th degree of Fahrenheit is 2 degree higher than 72. So you can minus, okay, but you cannot divide. While in ratio, okay, you can have 0 and you can divide. The 0 here means nil or nothing. Okay, so in that case, usually ratio data type will have unit of measurement. Okay. So up to here, our lesson. Okay, so you read this slide. Okay, next week we will have quiz in the beginning of the class. Just 5-minute quiz.
Sir,
Yes.
I'm not wrong, next week is holiday, sir.
Oh, next week is holiday. Okay, then next week we will have quiz.
For the assignment, the deadline,
The deadline next 2 weeks. Then.
okay, so wait, let me clarify, sir. There is how many assignment?
Yeah, there is an assignment and then there is a quiz next meeting about the measurement of scale.
Oh, the
The assignment I
data.
will put in Lentera today.
Oh, okay. The assignment you put and the quiz.
Yeah,
Is
the
that it?
assignment you can use Excel.
Okay, sir. Thank you.
Thank you. If you want to show your QR code, it's okay. Or you already absent all of them.
I'll do it manually, sir.
Thank you. So see you next 2 weeks.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Yes, sir.